Hey, good afternoon once again, options traders. And I thought this might be a little bit of a fun video to talk about the math behind the square root pricing rule. And we've talked about this so many times before, this kind of an odd sounding pricing relationship between the time to expiration versus an options price. Now, this applies to the at the money options only, but it's still kind of nice to understand the intuition behind it so that you have a better feel for this pricing relationship. So we'll find out what's causing this kind of odd relationship, and then we'll also talk about why it matters to you as a trader. So before we get started, as always, please be sure to click like and subscribe. It is greatly appreciated and helps so much to promote the channel. So a quick review. Remember what the square root pricing rule is for those who might be new. What it says is that it takes about 4 times the amount of time to double an option's price. Again, this is for at the money options only. And the reason is that option prices are proportional to volatility, and volatility is proportional to the square root of time. So that's also what's really causing this odd relationship. So here's what it means, that if we have a 1-month option trading for $1 and we wonder what the 4-month option should be trading for. Well, if you're going to ask most traders, they would tell you it should be trading for $4. And that makes sense because it has 4 times the amount of time. But that's actually not right. And here's the way that we figure it out. We say how much time is there between the first and the second option, and we're going to say there is 4 times the amount of time. We take the square root of 4, that comes up to 2. And that tells us that the pricing relationship between this first and second option should be a factor of 2. So if this first option is trading for $1, the second option should be trading for 2. If this first option were trading for 3, we would expect the 4-month option to be trading for 6. It's always going to be twice as much, roughly speaking, at least according to a pricing model this would be true. In the real world, because of skews, they should be close, but they might not be exact. But as long as it's a 1-month versus a 4-month, or a 4-month versus a 16-month, as long as we have 4 times the amount of time, this pricing relationship will occur. So what's the intuition behind it, rather than saying, well, option prices are proportional to volatility? Well, here's kind of a neat little way to look at it. Let's take a couple of things that we can just count. Let's say letters. We could use numbers, we could use apples and oranges, anything would work. But let's just use A and B. Now, if we were to count how many unique pairings that we had of this, we'd say, well, obviously we could have an A and a B, but we can also reverse them and have B and A. So there's really only 2 unique pairings. Think of this as if you're drawing these out of a hat. You could either draw A then B or B then A. So with just 2 things in our set, we have 2 unique pairings. Now, the logic behind that, mathematically, we could say, well, there's 2 ways to draw the first one, and because they're independent, I would have 1 way to draw the second one, so 2 times 1 would give me 2 unique pairings. Well, what if we double the things in our set from 2 to 4? So let's do A, B, C, D. Now we've got these unique pairings, and of course we can reverse them, and that's going to give us 12 unique pairings. And of course, the logic behind that is to say that we have 4 ways to draw the first one, and once we've drawn that, we would have 3 things remaining to draw from. So 4 times 3 would give us 12 unique pairings, and that's what we're seeing right here. Here's 6, and 6 of them reverse, so there's 12 unique pairings. Well, what if we double from 4 to 8? Now it's going to start getting complicated, but if we were to go through and list them all, we would get this. We'd find that there's 28, but we could also reverse them. Now, for just the sake of space, I'm not going to reverse them, but we could take every single pairing. AB would become BA, AC would become CA. We would do that for every single one. So we'd end up with 28 times 2, or 56. And of course, the logic there again is we have 8 ways to draw the first one, and then 7 ways to draw the second one. So 8 times 7 is 56. And that agrees with going about it the long way and trying to actually hammer them out. Okay, so what's happening with these sets? Well, when we started with just 2 things, A and B, we had 2 unique pairings. When we double it to 4, we went to 12. We doubled again to 8, we go to 56. If we had done it again with 16, we would have 240. You can see that these start to multiply out fairly quickly. But take a look at the ratios. If we take 12 unique pairings when we had 4 things in our set versus 2, if we divide those out, we get 6. What happens if we are comparing 8 to 4? Well, now we have 56 divided by 12. That comes up to 4.67. We do the next row. We go from 240 and 56. That comes up to 4.29. And look at that. This pattern is starting to close in on 4. And eventually, down here, we're going to hit 4 pretty close to exact. If we go out enough decimals, we'll probably never really hit 4 exactly, but we're going to start getting really, really close. And once we do, it's never going to change. So what's happening is that whenever we have 2 things to choose from, such as heads, tails, or A, B, if we're always picking 2, that we're going to get this type of an outcome. And that's really what's happening when we look at a bell curve. So for those who have had statistics, will remember the binomial distribution where you have 2 things, such as heads, tails, or male, female, 2 things that you can choose from. And when you do that enough times, when you start making that list very long, in other words, not going from 2 or 4, we're looking down here, you're going to start converging on 4. So here's what it means. Let's say that we had this array. Some of you might remember this as Galton's board, or I think it's called, is it Plinko? I think was a game on Price is Right. They used to do something similar to this. And you would drop a ball, let's say a ping pong ball through here, and it's going to bounce along, and it's going to drop into one of these bins down here at the bottom. Now, on average, they should fall straight here to the center, but they're not always going to do that. So if we did this enough times, we're going to start getting something like this, and it would start to form a bell curve. And what's happening here is that you can think of it as that the ball has to, let's say, flip a coin to decide if it's going to bounce left or right whenever it strikes a peg. Half the time it should go left, half the time it should go right. So on average, it should get an equal number of heads and tails and land very close to the center. But every once in a while, you'll get those odd kinds of sequences where it just lands nothing but heads, and you're going to land way out here. Or maybe the coin lands nothing but tails, and you're going to land way out here. So remember that improbable does not mean impossible. If you toss a coin 1,024 times, you will probably get 10 heads in a row in one of those sequences. So yes, it might sound highly unlikely to get 10 heads in a row, but that's if you're only doing it one time. So that's what's really causing this relationship. And so if we were to raise our little funnel up here 4 times the height, we should get twice the spread in the distribution. It would have to fall 4 times as long in order to get twice that spread, and that's what's going to double that option's price. So it really just comes down to the statistics of it and the math of it, but I thought this might be a little bit more of an intuitive way to understand what's happening. So why is this important? Why does it matter for traders? Well, remember, all things being equal, traders should prefer to buy longer dated options and sell shorter dated options. That's really the key to remember. So let's go back to our 1-month option trading for $1 and the 4-month option trading for $2. If you were the seller of the option, you should prefer, again, all things being equal, to sell the 1-month option 4 different times. Every single month you're going to sell this and collect $1 because that would give you $4 instead of selling the 4-month one time and collecting only $2. You would collect twice as much money. On the other hand, if you're the buyer of the option, you should prefer to buy the 4-month because now it would just cost you $2 as opposed to spending $4. And so you would just be spending twice as much money to cover the same time. Now also remember, this is why I keep saying all things being equal. You're not necessarily guaranteed to be able to sell this option 4 times in a row for $1. You might sell it one time, find out that the stock tanks, and now you really can't sell any more options until the stock recovers, at least without potentially locking yourself into a loss. But if you sell the 4-month option, you now have twice the size of a hedge. So sometimes the hedging dimension comes into your decisions, which is fine. But again, all things being equal, if you're looking at it just from a financial perspective and assuming that that stock price is going to remain fairly calm and that the volatility is going to remain the same, you should prefer to sell shorter dated options and buy longer dated ones. And it's the square root pricing rule that gives us that motivation. And for anyone who'd like to learn more about the art and science of options trading, please check out the Alpha Trader course, Strategy Lab, and a technical analysis course. It's all at optionsatoz.com. Also, please join us on Options A to Z's Facebook trading group, and you can find a link in the description below.